Hi, class. You'll be seeing lots of different views of different objects as you work through this course. And I want I want to be sure that what you're looking at is clear to you. And if it sometimes isn't, please do ask or come back to this page for help. Let's start with the familiar road map, looking down from above. So when we talk about map view, we mean the view from above. So this might be a paper map, like this one is, and you're often looking at map views on Google Maps and Google Earth as well. But of course, they can do a lot more than that, and we'll be using some of those capabilities in this course. This is the home page for hikearizona.com. I love this site. It provides map views of various types. We'll take a look at this column for new guides and routes, and just click on the first one there. This section is where you'll find the most complete information, and not just topographic maps for the hikes, but topographic maps. So we can scroll down here. So here's a map. We can make this full screen. Okay, so one type of topographic map here has all these brown squiggly lines, which is pretty common. And what these lines are each line connects points of equal elevation. So this line has a 3100 written on it, and all along that line, wherever it goes, is 3100 feet. We'll get into topographic maps more later on. Basically, though, when contour lines are closer together, the land is steeper. Okay, so here you have much closer spacing than out here. And that makes sense because this is a peak. This is a mountain to be steeper than the surrounding lands. Simple, right? And then we look over here, and this is different layers. This that we're looking at, the US topo, Hike Arizona topos are also nice and show some colors, so some features stand out more. There are some other differences too. And they have a couple of other choices also. Hike Arizona also provides a profile of the hike. We'll minimize this map in the upper left-hand corner, and you can actually see the profile of the hike. So along the line that's drawn below that shows the trail that someone took, right down in here, okay, you can see where it's going to be steepest, where it's going to be less steep. You can tell the elevation on this side. So it's hike from street view, and drawing a line along the top edge or skyline of whatever features are there. Before Google Earth and its ability to generate profiles, classes and hikers and such would go through a tedious paper and pencil process to get a profile. You should have a chance to make a profile on Google Maps later in the semester. Next up is geologic maps. So here is a geologic map of Arizona. Geologic maps are colorful, very colorful, so they're fun to look at. They may even make good wall hangings and such. Each of the different colors represents a different age of rock unit. There's a key over here for all that. There are a lot of other pieces of information all over this map. Sometimes a geologic map will include topo lines. It also shows where different types and ages of rock are located across the mapped area at Earth's surface or just below the soil and plants. So if you could scrape off everything above rock, bedrock, these would be the ages of the rock that you'd see. They also show lines along which there's been movement of the rock. And there are geologic highway maps. So besides this information, and maybe the topo lines, the contour lines, you also have highways, and sometimes some other roads on the map. Next up, the cross sections. We'll be looking at cross sections of the Earth to show its internal structure made of layers. It's like cutting through the Earth and looking at one of the flat surfaces that results from the side, like cutting through an apple horizontally, in this case shown. Actually, this is not too bad a model for what is going on in the Earth. Outer part, the crust, the skin of the apple, and wide area underneath that would be the mantle, and then the outer core would be this dotted area within there, and then the inner core would be the star-like shape. But that's not perfect. Maybe we could just say the very inner part of that. Anyway, that's what the cross sections are. Well, this looks like a bump here. It's an actual cross section would go through that also, so it's smooth. Here's a sandwich in map view. If you cut along that black line and look at the side view, you see a cross section of that sandwich. The profile would be a straight line, or a slightly dipping line in the middle. Here's that cross section again. And here's a geology block diagram. If I had tipped and turned that sandwich a bit and took another photo, you could see both the map view and cross sections of two sides. But I ate the sandwich and now I don't want another one for a while. Sorry, but you'll have to use your imagination. Sometimes geologic models and diagrams, like this one shows, like this one, will show both what's going on inside the Earth, the sides here, the cross sections, and at the surface at the same time. So here's your map view and two different cross-section views. The profile would be flat, though sometimes these blocks will show on the top surface, little 3D to show topography, the highs and lows of the land, and even vegetation sometimes. An important thing to notice here is that just because the ground is flat doesn't necessarily mean that the rock layers below it are also flat. Looking at this, looks like you have an arch in the rock, and when you look and see an arch over on this cross section also, together it means you're looking at a dome. On the top, it doesn't look like a dome anymore because erosion has flattened it. Okay, I'll stop there. I hope this will be a good reference for you if you need to remember what is what in the world of maps and cross sections. Thanks for listening. Bye.